Good afternoon. This is Dr. Brian Crable. I'm an assistant professor of microbiology at the University of Scranton in Northeast Pennsylvania. I wanted to bring together a video series on epidemiology at this point in the semester because, as many of you know, and like many colleges and universities around the nation, we have decided to extend spring break for our students by 1 week and then cancel face-to-face classes and resume with remote-only instruction starting on March 30th. We did this in response to the global COVID-19 outbreak. And I think even though I typically cover epidemiology later in the semester, I think right now is a fantastic time to put together a video series on epidemiology, looking at understanding infection, disease, transmission, and epidemiology. Because I think right now is an opportunity for our students just living to reinforce the learning objectives for the section on epidemiology. It's timely. And I also think as our students go home for spring break, they'll face a number of questions from their parents, from their cousins, from their nieces and nephews, brothers and sisters. And I think given that they are taking a microbiology course, I think it's important to give them the resources to be able to answer those questions. For that reason, I'm pushing this video series right now really hard to try and get it online before students leave or shortly after they leave and arrive home. For my students, I want to emphasize you're not obligated to go through this video series during spring break, but I want to make this available to you as a resource as you're transitioning away from the university into your homes, preparing for an extended spring break, and then preparing for remote instruction starting on March 30th. So why am I making this video series? Well, as I mentioned, the COVID-19 outbreak has led the University of Scranton to cancel face-to-face classes. At least for the next 30 days, we'll be transitioning to remote instruction starting March 30th. Over the last few days, as we as a university community have been preparing for this, I've had a number of students that have come to me with very timely and very important questions regarding COVID-19, how they can protect themselves, how they can protect their family, whether the actions being taken by colleges and universities around the nation, by the NCAA, by professional sports, by professional musicians canceling concerts, whether those reactions are appropriate, whether they're an overreaction. And I think these are all very poignant and very important questions. So a number of students have asked me how bad it is, how they should react or how they should interact. A number of students have told me that they've had parents coming to them, calling them, asking questions, and their response has been, well, we haven't studied epidemiology yet, so they don't really know what to tell them, or they're giving them the same information that they hear. Maybe it's good information, maybe it's not, and they don't really have the tool set right now to be able to navigate those conversations and to understand what is reasonable information, what's reliable information, and what might be misinformation. I do want to emphasize a couple things. So this video series, I am preparing as remote instruction for my microbiology course, Bio 250 at the University of Scranton. So it will focus on the learning objectives that I have for the epidemiology section of the course. Typically that epidemiology section comes towards the end of the semester. I have decided to move this up and present this as sort of the first module for remote instruction, given what is going on in the news and given the timeliness of epidemiology and understanding patterns of transmission. I also want to make this available as a community resource. I recognize that my students, the 64 that I have this semester, aren't the only ones at the University of Scranton who may have questions about epidemiology and transmission of infections. So I do want to rely heavily on public domain teaching resources. So for my students who have their textbook, the information we cover in here is also in your textbook, but you should also use your textbook for additional clarification. But I do want to make this available as a resource that can be spread throughout the community and handed to your parents or shown to your brothers and sisters so that they can also start to navigate the difficult issues surrounding, well, what information is good information, what isn't so reliable, and what might be outright misinformation. So thank you for understanding that, and we'll continue with the next slide. So my students know who I am, but again, one of the purposes, one of the goals of this video series is to make this more broadly available to folks within the university community, folks affiliated with the university who may not have had me for class, who may not work in the same department as me. So I just wanted to take a few seconds and introduce you to my background, to my role at the university, and clarify above all that I'm not an epidemiologist. So what we talk about in here will be good faith effort to convey the most accurate, up-to-date information. But again, and we'll talk about this on the next slide. But again, I'm not an epidemiologist. My background is in microbial system science, microbial physiology, environmental microbiology. But with that in mind, I have taught both the Bio 210 clinical micro course at the University of Scranton, as well as this semester I'm teaching the Bio 250, the microbiology course that's geared towards our biology majors, as well as chemistry majors and physics majors. So I got my undergraduate degree, Bachelor's of Science in Biology at St. Vincent College. From there, I moved to Duquesne University, where I earned a Master's of Science degree in John Stoltz's lab, working on the environmental transformation of roxarsone. It was an organoarsenical food additive used in the poultry industry that could be transformed into arsenic and could cause some issues for folks living near what are called concentrated agricultural feeding operations, or CAFOs. When I finished in John's lab, I moved to the University of Oklahoma in Mike McInerney's lab, where I looked at basically energy conservation and electron flux in a metabolic interdependency. That's a lot to take in. Basically, we were just looking at how two organisms could work together to do something that neither organism could do alone. From there, I moved to Oak Ridge National Laboratory for a postdoc. I worked on microbial methylation of mercury, so basically looking at how elemental mercury, the stuff from thermometers or the little maze toys or that might be in a filling, looking at how that was converted to methylmercury, which is a potent neurotoxin and has caused a lot of devastation around the world. After finishing my fellowship at Oak Ridge, I moved to the Air Force Research Laboratory. I was a research scientist with a contractor there, UES Incorporated. There I worked on the microbial degradation of polyurethane, so basically looking at polyurethane integrity in what are called built environments or engineered environments. So basically looking at how microbes cause problems for things like aircrafts or underground storage tanks or pipelines or those types of environments. I moved to the University of Scranton in 2018, so this is my second year. As I mentioned, my first year I taught Bio 210, the clinical micro course, as part of our nursing program, and then this year I'm teaching Bio 250, which is the micro course for our bio majors. Again, my background is in microbial system science or microbial physiology or environmental microbiology, but I am broadly trained in microbiology in general, and I think a lot of the patterns that we see with respect to how microbes move in the environment are immediately adaptable and very highly related to things that we want to talk about with respect to transmission of infection and how we keep ourselves safe and keep our communities safe during this particular outbreak. Okay. So thank you for following along so far. I again want to emphasize I'm not an epidemiologist. I will, throughout the video series, make specific recommendations that are based on good hygiene in general. I'm not comfortable distinguishing between bacterial diseases or viral diseases or infections, which coronavirus or COVID-19 is a viral infection. But I do want to emphasize that there are a number of practices that we can employ both with bacterial infections as well as viral infections that will help minimize the risk of transmission, slow down the rate of transmission, and overall help keep us, help keep our families, help keep our communities safe, and really sort of, as they say, try and flatten that curve, right? So we don't want a whole bunch of people getting sick at the same time. We would rather spread that out over several months so that we don't overwhelm our healthcare facilities. With that in mind, any specific recommendations that I do make are focused on good hygiene in general. They're not specific to COVID 19 or coronavirus. And you should recognize that where there is any conflict between any recommendation that I make and official guidance from the Centers for Disease Control, you should defer to the official guidance from the Center for Disease Control. I want to thank everybody for their patience throughout this video series. As I'm sure you can understand, I'm suddenly transitioning from in-class lectures to remote instruction via a narrated PowerPoint. I'm also trying to learn the technology as we go along, and against this backdrop, COVID-19 is the situation with COVID-19 is extremely fluid. If you had asked me 2 months ago when I heard about the United States starting to screen some passengers arriving at LAX from Wuhan province for this particular infection, I would have never thought that 2 or 3 months later we would be in a situation where March Madness was canceled, the stock market had crashed, over 20%. Colleges and universities were suspending face-to-face instruction and transitioning to online or remote instruction. I would have never anticipated that 2 or 3 months ago. So again, the situation with respect to COVID-19 is extremely fluid. I am trying to put this up online by about March 14th so that as students are going home for spring break and transition to remote instruction, they'll be able to have this available as a resource to answer questions from their family members. For those of you who are interested, the class uses a textbook called Brock Biology of Microorganisms, the 15th edition. That's our textbook. I do want to try and make this as broadly accessible as possible. So for the purpose of the video series, I'm going to rely on information that I believe to be in the public domain. With that in mind, if you find this information interesting, Brock is an excellent textbook. And there are older editions, so 12th, 13th, and 14th editions are available on Amazon for about $10. With that in mind, students who are in my course, you should consult your edition of Brock for additional clarification. You should also monitor the discussion boards that we'll have up on Desire to Learn, as well as interact with me through those remote those tools, so that we can continue the conversation beyond just the video series. So again, I want to thank everybody for your patience. I really look forward to getting this video series together and getting it online. And I hopefully folks in the community will find it useful. So thank you very much.